solve inequalities is very similar to solving an equation. And the only place we need to be careful is we need to remember to flip the sign, flip the inequality sign when we divide both sides by a negative, or when we multiply both sides by a negative. So when we divide both sides of the equation, inequality, both sides, or multiply by a negative, all the other steps will be exactly the same as solving an equation. We can add or subtract a number, or multiply or divide a positive number both sides. They won't affect the sign. The only time that will affect the sign is when we multiply or divide a negative number. So let's look at the problem. X minus 3 minus 2 times 2x minus 5 greater than or equal to 2 times x plus 1. So first of all, we want to, just like solving equations, we want to get rid of the parentheses. And there's not a number in front of the first pair of parentheses. We can put 1 there. So we're going to distribute 1 to both of them. We distribute negative 2 to both of them, distribute 2 to both of them. Again, to help you avoid mistake, you can put the number on top of each pair of parentheses, 2 terms. So we are doing 1 times x, x, 1 times negative 3, negative 3. Negative 2 times 2x, negative 4x, negative 2 times negative 5, positive 10. It's greater than or equal to 2 times x, 2x, 2 times 1, it's positive 2. Now we're going to combine like terms. X is like 1x, so 1x minus 4x, that's negative 3x, because 1 minus 4 is negative 3. And negative 3 plus 10, that gives us positive 7, greater than or equal to 2x plus 2. And now we're going to add 3x to both sides, because to combine these two like terms, we have to move one of them to the other side so we can combine. And now we end up with 7 greater than or equal to 5x plus 2. And to get this x by itself, we're going to have to subtract 2 from both sides. 5 is greater than or equal to x. And then we get rid of that 5 by dividing, 5x here, we divide both sides by 5. And that gives us 1 is greater than or equal to x. And notice right here, there is another solution. Instead of adding 3x to both sides, another option is to subtract 2x from both sides. To move that 2x to the left instead of moving that negative 3x to the right. If we do this, we're going to end up with negative 5x plus 7 greater than or equal to 2. And then subtract the 7, we get negative 5x is greater than or equal to negative 5. And here is where we have to pay attention, because in order to get rid of negative 5, we need to divide both sides by a negative number, negative 5. By this rule, when we divide both sides by a negative number, we must remember to flip the sign. So now we get negative divided by negative is positive, and the 5 divided by 5 is 1, less than or equal to positive 1. And they are the same answer, because alligator's mouth is pointing toward the smaller one, which means x is smaller, and the same here, x is smaller. Only difference is in the first solution we have x on the right, but the second solution we have x on the left. But they both mean the same thing. 1 is greater than x, or x is less than 1. That means the same thing. So that's how we solve an inequality. Just like solving equations, but if you're going to divide both sides by a negative number, make sure you flip the sign. And next thing we want to do is to graph the solution. Usually it would be easier, you won't make mistakes when you do the graphing if x is on the left hand side. Because when we graph, we want to graph all the numbers that is smaller than or equal to 1. So this inequality, if we put it in English sentence, it means x is smaller or less than, x is less than or equal to 1. Well, so let's put a 1 on the number line here. And what numbers on the number line, what numbers are smaller than 1? Apparently, it's the numbers on the left side of 1. If you don't have a red color, you can raise the line and draw the line toward left, and that's the numbers we're talking about under the line. The other thing we got to pay attention is because there's an equal sign to indicate x can be equal to 1, we are going to put a closed dot right here. So that's the graph. If you had this one, you also should have the same answer, because although the sign looks like a greater than, but we're graphing the numbers for x, and x is still smaller than x. When you read this, x is still smaller than 1, which means you still have to highlight the numbers on the left side of 1. Also, of course, there's an equal sign, smaller than or equal to 1. So that's the graph. After we have the graph, to do the Intima notation, we write down the left end number. There's not a left end. We use negative infinity to denote that. And comma, and the right end, that's 1. If x can be equal to, so it's a closed dot, which means x can be equal to, we use bracket, square bracket. And then if it's infinity, we cannot reach there, we use parentheses, which means x cannot be equal to negative infinity, but it's getting to infinity, negative infinity. So that's called interval notation. All right, now let's look at another example of a compound inequality. So compound means more than 1. So we have two inequalities, x greater than 1 and x less than 3. And these two together, by the way, we're not solving two inequalities. After we get the answer, we have to put them together. So this is one problem. Now, first we're going to graph each one. X is greater than 1. 1 is here, 3 is there. Greater than 1, which means the numbers on the right. So we're going to draw an open circle because x cannot be equal to 1, and raise the line to the right. And I'm going to use the blue color for the other second inequality, for x less than 3. So for 3, we draw again an open circle because x is not equal to 3. And because x is less than 3, we are going to go towards the left. And now let's take a look. We have the conjunction word and. And means it cannot be one or the other. It has to be numbers that meet both requirements. So as we can see, these are the numbers that can meet both requirements because they're not only greater than 1. See, they're under the red line. They're also under the blue line. That means they are but also less than 3. So these are the numbers that meet both requirements. So that's the graph. And if you want to use the interval notation to describe it, the left end is 1, the right end is 3, because we want to exclude 1 or 3, which means x cannot be equal to 1 and 3. We use parentheses. So that's the graph and interval notation. Just a side note, if we change the word between them to or, the graph, when we graph each one, they will still look the same, but the final graph will be different. Say x is greater than 1, we still take the numbers to the right of 1. X is less than 3, we still take numbers to the left of 3. But because of the or means you don't have to be under both lines. You don't have to meet both requirements. You just need to meet one of the requirements. So let's look for the numbers that can meet one requirements. So these numbers will be smaller than 3. all of these, they meet one of them. And we can continue because all of these numbers are greater than 1 because they're under the red line. So which means all the numbers are solutions. So if we use the Intima notation, that would be the left end negative infinity and the right end positive infinity. In other words, all numbers, all real numbers, will be our solutions. So you can see the word between joining the two inequalities makes a big difference. So if it's and, we only get numbers between 1 and 3. If it's or, we got all of them.